When we think of an operating room, we picture this perfectly sterile, controlled world, right? Where every single risk is managed. But what if it's not? What if there's an invisible hazard, one that's present in pretty much every surgery but often goes completely overlooked? Well, today we're clearing the air on surgical smoke.
So every time a surgeon uses one of those heat-generating instruments to cut or cauterize, it creates this plume of smoke. And yeah, you might just write it off as a bad smell, but the real question is, what's actually in that plume? What are these surgical teams breathing in and day out?
Okay, so the official scientific term for this stuff is surgical smoke, and it's exactly what it sounds like. It's created when surgical tools literally vaporize human tissue. The cell walls just burst, and all their contents are released into the air. So this is definitely not just steam. It's a really complex aerosol made of biological matter. Now, when you look at the breakdown, that 95% water vapor part might seem reassuring. But here's the catch. The real danger is hiding in the other 5%. We're talking about a nasty cocktail of chemicals like carbon monoxide, tiny fragments of blood and tissue, and even living, viable viruses and bacteria. That tiny little fraction, that's the whole reason we're talking about this. And believe me, this is not a small-scale issue. The U.S. Occupational Safety and Health Administration, that's OSHA, they estimate that over 500,000 healthcare workers are exposed to surgical smoke every single year. Let that sink in. 500,000 people are breathing this stuff in just as part of their job.
So yeah, all of this really points to a widespread, yet often totally invisible hazard right there in the operating room. For decades, the challenge has been just trying to understand how big the problem really is.
But how do you even begin to get a handle on a problem this big? I mean, you can't just look at one or two studies. You need to map the entire universe of research. And that's exactly what a team of scientists recently decided to do. They use this really cool method called bibliometric analysis. I know, it sounds super complex, but it's actually a pretty straightforward idea. It's a way to analyze the research papers themselves. You use data to see who's publishing, what they're focusing on, which papers are making the biggest splash, and how all these ideas connect over time. Here's the best way to think about it. Instead of getting lost in the weeds of hundreds of individual papers, this analysis gives you a high-level, satellite view of everything. It shows you the big continents of thought, the major highways of influence between different researchers, and even the emerging hotspots where new discoveries are being made. And their process for building this map was incredibly methodical. They used a major scientific database called Scopus and did their search on a single day to get a perfect snapshot in time. Using specific keywords, they narrowed it all down to 51 key studies published over about 2 decades. And that became the data set for their map. Okay, so they built this comprehensive map. What did it actually show them? What can 20 years of research tell us about the risks of surgical smoke? Well, the first big thing that jumped out was a timeline of scientific interest. For years, there was a pretty steady stream of research. And then boom, something happened in 2021. The number of publications suddenly spiked. In fact, 11 of the 51 studies they looked at, that's over 20% of the total, were published in that 1 year alone. So why the sudden surge? The researchers have a pretty compelling theory: the COVID-19 pandemic. All of a sudden, the entire world, and especially the medical community, became hyper-aware of airborne and respiratory risks. It makes sense that this global focus would bring a whole new level of attention to the long-standing issue of surgical smoke. The map also showed where all this research is happening. The United States is clearly leading the charge, producing over a quarter of all the studies. But this is very much a global conversation, with really important contributions coming from researchers in places like China, Iran, Turkey, and Thailand. And get this, the analysis also pointed out the most influential papers, the ones that other scientists keep referencing over and over again. And one paper from way back in 2003 by Barrett and Garber just completely stands out. It's been cited 250 times. It was such a foundational review of the topic that even 2 decades later, it's still considered the cornerstone of the entire field. So, the map shows us who is studying the problem and which papers are the most important. But what does all of this actually mean for the safety of the people in the operating room every day? This right here might be the single most critical takeaway from all this research, and I'm just going to read it directly. Standard surgical masks, commonly used by surgical teams, are inadequate to effectively filter ultrafine particles of surgical smoke. And here's why that is so important. A standard surgical mask lets particles smaller than zero point 0.1 micrograms pass right on through. But surgical smoke? Well, it's packed with exactly those kinds of ultrafine particles, chemicals, and viruses. It's a fundamental mismatch between the protection being used and the hazard that's actually there. Understanding this massive gap is crucial. This research map doesn't just show us where we've been, it gives us a really clear direction for where we need to go to chart a much safer future in our operating rooms. For the nurses and other professionals on the front lines, the implications are crystal clear. This whole analysis just highlights the need to raise awareness, to advocate for better safety measures like smoke evacuation systems, and to use this mountain of evidence to push for safer standards for the entire surgical team. And for the scientific community, well, the map reveals the roads not yet taken. The analysis is basically a call to action for new research into the long-term health effects of this exposure. It shines a spotlight on the need to test how well our current safety gear actually works and to develop new technologies to clear the air more effectively. In the end, this analysis has given us a clear, satellite-level map of an invisible danger. We can see its components, we understand the scale of exposure, and we know about the huge gaps in our protection. So the question is no longer what's in the air. The real question is, now that we have this map at our hands, how do we finally clear the air for good?